Hello. In this video we're going to be talking about both tangent lines and limits. So we're going to take the work that we've done so far this unit and we are going to put them together. So let me start by drawing a function for us. There we go. There's one. And so let's say we want to find the slope of the tangent line. So find the slope of the tangent line at this point I drew, and I'll name it a comma, and I know since it's a function I can just input that and get f of a, whatever it is. So that'll be my ordered pair, a comma f of a. And so we're finding the slope of our tangent line at the point a, or where x is equal to a. So what we did in the previous sections is we drew a bunch of secant lines so that, and I'll call this Q, and we found the slope of this, and then here's another one, I'll call this Q, there we go, and then we drew another one, and I'll call this Q as well. So, and we noticed that as we got our Q got closer and closer and closer to our functions a comma f of a, the slope of that secant line approached the slope of the tangent line. And that's what we did previously. We made a whole bunch of x and y charts, and we made an attempt to find the slope of all of those secant lines just to see what number it would be approaching so that we could find the slope of the tangent line. And so let's consider one of these point Q's. And so if I consider Q to be at x comma f of x, I don't know what our values are, just like I don't know what a is, so I'll just call it x and f of x. So I'm inputting x, I'm outputting f of x. And we can find the slope for this line, this secant. We would do f of x minus f of a, right? I've subtracted my y's, now I'm going to subtract my x's, x minus a. And that's all well and good for helping us find the slope of our secant line, but that's not what we want. We want the slope of our tangent line. So we talked about how the secants are approaching that point. Well, if we're doing an approach, that means we can talk about it as a limit. And we're talking about our limit as our x value is approaching the number a, right? As our q's get closer to a comma f of a, where we're looking for our point of tangency. And we want a to approach, or x to approach a, while using this slope formula. Because I don't care about what it is for the function, I care about what the slope is going to be. So we can use this, the limit as x approaches a of our slope. And so this right here is the answer to our question. The slope of our tangent line at the point a is the limit as we approach a of f of x minus f of a all over x minus a. Right? It's just the limit of us doing our slope formula. So let's use this in an example. So in this example, we want to find the equation of our tangent line, and we're going to have our point of tangency at 1, 1 on the curve y equals x cubed. So what do we do here? Well, in order to write the equation for a line, we need to know two things: the slope and the y-intercept, or the slope and a point. So how do we find the slope? Well, we'll use that limit we just came up with. And we're approaching the point 1, 1, so my x is approaching a value of 1 of f of x minus f of 1. There we go. I've written that correctly finally. Over x minus 1. So to fill this in, f of x is the same as x cubed minus f of 1, well, we see already that that's 1, right? Or I could just do y equals 1 cubed and get 1, over x minus 1. And we can factor this. So let me fill that in a minute as we approach 1. We can factor this into x minus 1 times x squared plus x plus 1 all over x minus 1. And so the x minus 1's will cancel, and the limit as we approach 1 will be the same as, or limit as we approach 1 is now being evaluated at x squared plus x plus 1. And since we are continuous everywhere on this particular parabola, I'm able to just plug this in. So we'll do 1 squared plus 1 plus 1, we end up getting 3. So the slope of this tangent line is 3. So now we want to find the equation of this. I have my point 1 comma 1. If we want to look at it as y equals mx plus b, well, I have a y value of 1, an m of 3, an x value of 1, then plus b. So simplifying that up shows me that b is going to end up being negative 2. So we can look at this as y equals 3x minus 2. And so if I graph, I'll just draw a rough sketch of this down here. And y equals x cubed sort of looks like this. And if there's 1 comma 1, and we draw in our tangent line at that spot, we're going to have a y-intercept of negative 2 and a slope of 3. So this picture really illustrates the line that we came up with. And so make sure you have that limit to help find the slope of the tangent lines in your notes so that we can use it tomorrow. For now, we are done.